So none of the substitutions that we've done to this point have involved the inverse trig function, so we're going to look at a few examples that do involve inverse trig functions. And they're a lot like the natural log. When you see a natural log in your integrand, usually your best bet is to try to substitute in for it and hope that the right integrating factor is there. That's sort of the same thing with inverse trig function. So I'm going to substitute in for the tangent inverse. And what I get when I do that is du is 1 over 1 plus x squared dx. Well, you can see that once I substitute in for this, cover it up, what's left is 1 over 1 plus x squared dx. So this one's been set up to work really nice. I'm going to put the u in, and then what's left gets replaced nicely by du. So I end up with, in this particular example, natural log of absolute value u plus a constant. And that's going to be natural log of the tangent inverse plus a constant. So here's a second example, very similar reasoning. If I see a sine inverse in the problem, I probably should substitute in for it. Well, this one's got another reason for substituting, because that sine inverse is inside of this tangent function. So I'm going to use the fact that if I should substitute in for that inside function and check if I get the right integrating factor. Du, the derivative of sine inverse, is 1 over the square root of 1 minus x squared, and then dx. So I can see that if I do this substitution, I'm going to get a tangent of u, and what's left is 1 over square root 1 minus x squared dx. So it's exactly what I needed. So that's going to turn in, everything else will disappear as du. And then remember, this is one of our new ones that's in the list. This is natural log of the absolute value of secant u plus a constant. Anytime I can get it down now to any trig function, I can evaluate. I just have to remember what the formula is. We know sine and cosine, but we got the 4 new ones. Anyway, getting back to taking the u back out of here by using this substitution, I get natural log of secant of sine inverse of x plus 1 plus a constant. So we can use these just like any other substitution. I mean, the inverse trig functions sometimes show up just like logarithms, just like trig functions or whatever. And so these were our standard substitutions, but now we want to look at a situation where the inverse trig function is, we're trying to make a substitution to turn it into an inverse trig function. So those will come in the next video.